Hello everyone, this is Pamperchew. Today I wanted to do a small video on how I've been practicing data forensics and recovery. So what I usually do is take a flash drive, break it in half, whatever, and then attempt to recover data from it. Sometimes I'll use cell phones or whatever I have that's just laying around that's going to get torn apart anyway. So this little drive here, I don't know where it came from. I just found it in one of my containers I had. It looked like I had damaged it a long time ago, or someone had. And what I did, you can see the pads where the original USB port was have been ripped off. I guess I can point. So those three pads right there have been ripped off, and that one's okay. And what I do is I try to solder something to it, to the wire that was there, so I can power it up and get the data off. In this case, there it is. In this case, I just soldered one wire to the wire here, and another one to this wire here. And those are the two data lines. And then over here, this was the positive power, and then ground. So here's the finished product. This is a StorageTek Anand 256 W3A2B. So it's probably 256 megabit, which would come out to 16 megabytes, I think. Well, let's go see. Okay, so I'm going to plug it in and see what comes up. USB device not recognized. Still getting an unknown device. Update driver. Compatible USB storage device. Let's try it. Device cannot start. So right now I'm unable to read it. I'm going to go and check the soldering. It appears that this flash drive had a oscillator on a crystal oscillator on board, and I must have taken it off and forgot to put one back. So probably needs that to function. Where are my crystals? And there they are. So I just need a baby oscillator. It's in here somewhere. A little round type, like that. These are generally always the same frequency. Find one that's a little bit smaller. Okay, I'll use that one, I guess. This here says these round cylinder kind are usually for timekeeping, and I don't know why, but every watch, everything that keeps time has this style packaging. All right, there it is, installed. Let's see if it'll work now. Hello everyone, this is Pamperchew. Today I've been doing a bunch of soldering, putting chips that are memory chips onto the little boards with pins so I can put them in the reader and see what's on them. This is I can get the angle right. It's a memory chip. Here's another one. So let's take one of these chips and I'll show you how it's read in the reader. Once I desolder it from a board, I sort out the chips that look interesting. This 93C46 lets me know that it's the 93C part. It lets me know that it's an EEPROM. And the 46, I don't remember what it means, but it's the size of the chip. So I can just stick that in here now. Once I put this into the reader, I load the program and type in the chip number. Now this one here is the 93C46S. 93C46S. And I will click on this second one. No, the first one. It really doesn't matter. It's the same thing. And this is it's a very small memory. Read it and see what's on it. So nothing much there, but that's what was on it. And I can erase that or change it and fill it with blank. Okay, so now that this is all typed in, I can go ahead and program it into the little memory, and it's done. So now I can clear the buffer, take the chip out, put the chip back in, make sure all the bits are shaken up. Sometimes they settle to the bottom and you don't get an accurate reading. There we go. And I'm going to read it. And it works. So this is quite fun to find all these chips on random boards, and sometimes they have information on them. Here's one that I found out of a Hayes modem. This is a fairly large and old EEPROM, an AM29 F400, and it has a special adapter to make it work. This one's not soldered on, this one's a socket, a ZIF socket for these type of chips. 29 F400, and read and read. Oops. Now it's reading. And it has an information about the people who made it, their names. I usually just save it as a text file and open it with a notepad. And so this was on that chip, US Robotics, and I think initiate the 8186 processor. Here's the CPU that was inside of it, the 8186. So I wanted to show another neat thing that I can do with this. This programmer and these chips that I find, besides reading information, data on them and finding out the little secrets about whatever device they came from, I can also store data on them like a floppy disk or USB flash drive. So this one here, I think, is a 4 megabyte. All I have to do in this program to store a file is go to open, and I'll do this old video here, sequence 12. I'm going to load it as a binary, and this is the actual video file. It looks like I ran over the space available, but just barely. That's not too big a deal. Since it's MPEG, it'll just play up until the point that the memory chip has filled up. So I'm going to program this now. Program. And this is going to take a while, so I'll speed this up. Right now it's erasing. And right now it's programming all 4 megabytes. Okay, so I have stored a video on this chip, and just for a demonstration I will show how to retrieve the file that I had saved on here. I saved it as a MP4, so let's see what happens. And so this is a MP4 video file that's been stored on the chip. Now, once I have it read into the buffer, I can save it, and I'll save it as test.mp4. Okay, and now it's been saved as a binary onto the desktop, and all I have to do is remove the binary file extension, and it is a video again. And there it is, and I can play it to prove it. Anyway, there's a look at some of the chip hacking modification stuff that I've been messing around with. Hope you enjoyed the video. Thanks for watching.